speaker. He is certified Scrum trainer and an Agile coach. He trained and certified thousands of Scrum masters and product owners in various organizations, from small companies and startups to multinational giants worldwide. Mr. Petri Heiramo with his speech by the power of the swarm. Big round of applause, please.
Good afternoon. Nice to be here again. Last year I talked about teamwork. Now I'm going to go into a concept that will enable teamwork and make it more powerful, make it easier to make happen in practice. So I will be talking about complex problems and swarming. So I will start by definition and talk a little about the foundations, and then at the end of the talk I will talk about a handful of practices, maybe 8 or 10, I've lost count. So I start with the question, what is a complex problem? I start that by eliminating a few different types of problems, and then we'll look at the complex problems. So simple problems are problems where we have an obvious solution. Something that we, in our daily life, we have a lot of simple problems, but we already know how to handle them, so we don't even notice that we are solving simple problems. Sometimes we do notice, but they are easy for us to handle. Complicated problems are ones where it is possible to find a clear solution, although it might not be an optimal solution, over time by combining, like breaking down the smaller problems and solving the parts individually and then combining the big solution. So things like planning factories or bridges or a lot of engineering tasks are complicated problems. They can be very complicated, require very specific expertise, but once you have a solution, you can apply that solution to multiple problems in that domain. Chaotic problems, on the other hand, are sort of like an extreme version of complex problems. The problem is that they don't usually have a clear solution. So you just have to figure something out and do something and then move on. Now, so somewhere between complicated and chaotic is the complex problems. Now, just like complicated problems, they have multiple competing factors that need to be considered simultaneously. In software context, we talk about things like compatibility, performance, testability, quality, productivity of the team, the limited time that we have available for doing it, and so on. So it's not okay to just think of performance if that means that, for example, you can't test it. So you have to deal with these issues simultaneously. The hard part about complex problems that definitely separates it from complicated ones is you can't break them into subparts. You can't take testability and just work on that problem. And once you have solved that you then take the next one. So you can't break it into subparts. You have to solve it as a whole. The connection between the different aspects are dynamic and nonlinear. And we don't even necessarily know all of them. There is no single optimal solution that we can reuse once we know it. We have to solve complex problems again every single time. Even when you try to solve a complex problems, if the first solution doesn't work, you have to rethink the problem again and solve it as a whole and try something else. So you can't sort of go from one step to another easily, at least, and consistently. So furthermore, complex problems are further complicated by the fact that, in hindsight, the solution is often obvious. I'll show you one where the solution is kind of obvious, but it's not obvious how you get there. It's not easy to say, oh, of course you solve problems like that. It requires innovation, coming up with new ideas or new novel ways of using existing ideas. Like this one, this problem. What do you do with rowdy, drunk people who make trouble? How do you get them not cause trouble? If you were engineering based, a person who has a strong engineering background, you're used to solving problems with technology. If you were posed with this original problem, you might have started thinking about maybe some constructions or noise cancelling devices or maybe, alcohol doesn't get you drunk or something like that, an engineering solution to the problem, all of which might have been very expensive and very difficult to come up with. And there's no guarantee that they would have worked. Just giving them lollipops. Somebody got that idea and solved the problem. Now, it doesn't solve the problem. Everywhere you have rowdy people who get drunk. It doesn't solve the problem maybe in this nightclub forever. People might get tired of the lollipops. We don't know. Things will change. So that's a complex problem. It's unique every single time. It's hard to solve. So when we solve these things and work on these problems, the solution is usually not something you can come up with the starting point. It emerges over time from your approaching that problem. When people interact and talk about this problem, they might connect things in a new way. Now, so they didn't invent lollipops for that problem. It was an existing solution for something else. People wanting to eat candy and not get their fingers dirty. So it was an old idea, but it was applied to a different circumstance in another way. Probably they tried other things before that didn't work. And there was no guarantee that the lollipop works either. So you usually have to refine. You have to experiment with something. You have to observe the outcome, what happens, learn from those things, and then try something different. So we need different viewpoints to solve a complex problem. The human problem, the thing that we have in our heads, the brain, is not very good at handling these multiple viewpoints at the same time. We have biases. Some people are able to handle maybe 2 or 3 viewpoints at a time and consider those, but there's way too many for a single person to hold in a real complex problem. So if the red circle thing is us and our thinking, the way we think, and then the holes are the effect, the blind spots our personalities create in us. Pretty obvious. We all know that we're not perfect. We think in certain ways, and we have biases in our thinking. Now, if we combine, some people, if we are alike with another person, that means it's very likely that the blind spots we have overlap. Pretty simple so far. The more people we add to this question, like in a teamwork, the more those sort of blind spots overlap, or don't overlap, and we help each other to solve. But even these teams can have blind spots. Now, the deepest problem with blind spots is that we don't see them. Every single one of you, and me too, we have a blind spot in our eyesight, in the field of vision. It's the point where the nerve goes into our brain. The visual nerve goes into our brain. Do we see that blind spot? How many of you see a blind spot in your daily life? It requires tricks. It's possible to perceive it and find where it is in your eyesight, but our brain compensates for it. That's what it does for every sort of the blind spot created by thinking. Our brain compensates for that. We think, even though there might be a major hole in the way we think, but as long as it matches our perceptions and our ways of thinking, we think like we solved the problem. Only when somebody else comes and points something that there's a blind spot, only then we can possibly see it. Sometimes we deny its existence. So if this is our problem, the circle, and solving the problem requires that we connect the dots, this problem will have a lot of trouble solving it. Now, even these two working together might do a better job, but they will have trouble. They will not be able to solve it in a way that solves the problem permanently. They might be a way forward, but it's not the ideal solution. The original team that we had before still can't do it, but can do a pretty good job. Variety is, of course, all kinds of things. Anything that makes us different. And the good thing about variety is the more we have it, the more easy it is for us to deal with complex problems. The bad thing about it, A, it's difficult to work with people who are significantly different from you, and 2, not all problems are complex. Complicated problems are not made easier by having variety. It's actually made more difficult. So complicated problems are solved by homogeneous people more easily than others. And of course, simple problems don't need a team. And to sort of recap this section is establishing an understanding that developing software is always a complex problem. So there are multiple different viewpoints that we do have to continuously integrate, as we talked before, the changing requirements, different skills we have, the need for technical quality, which is not just no bugs, but it is being able to write software that doesn't have bugs in as little time as possible, and maintainable and all other things. And on top of that, we need to continually improve at the way we work. So that's definitely a complex problem that doesn't have an obvious solution. Otherwise, we would already have solved this. There's so many people who've been thinking about this problem that it should have been solved by now. But it's complex, so it can't be solved permanently. So we have to resolve it. Now, then we go to swarming. The swarming is a concept that allows us to deal. It's the most effective single overall strategy for solving complex problems. The essence of swarming is more brains over bigger brain, or a better brain. Try think faster. Try thinking twice as fast. Does it work? Okay, if you can't think faster, try think slower. Okay, pretty hard, isn't it? So your brain thinks at a certain speed. You can't avoid it. What you can maybe control is what you use your brain for, but it keeps thinking at that same speed. That's how it operates. It also thinks at certain quality. If I ask you to, hey, think twice as well, not going to happen. You can think poorer by, for example, taking alcohol. A lot of alcohol and your brain starts thinking poorer. So that you can do, but without getting something to help you think poorer, you can't think poorer. You can purposefully ignore things, but that's a different thing. So in order for us, if we want to go faster, think faster, if we want to think better, we need to parallelize brains and make them think about the same problem at the same time. And that's swarming. So it has 4 components. It's more than one brain, thinking of the same problem together at the same time. So you need to have all 4 aspects in order for it to happen. So it's not okay, it's not swarming if you take a programming problem and one of you is working on the back end and the other person is working on the front end. That's not swarming, that's collaboration. Because you have a different problem you're trying to solve. Even if it's at the same time and you sit next to each other, so you're kind of solving, being together, but it's a different problem you're solving. So, I'm going to put use the rest of the presentation on looking at the different practices that we have available or we can use to create conditions for swarming or enable people to swarm, and consequently we get better teamwork as well. So, I'm going to start from the very biggest picture. It sounds like it's obvious, and it should be obvious, but a lot of teams don't do this. So if the product owner and the development team have a different perception of the thing that they're trying to do, the problem they're trying to solve, they can't think together. They think different problems. So you need to confirm that they think the same problem. Now, in other words, the product owner has to teach the team what the problem is. But also the team knows some aspects of the problem that the product owner doesn't have, so the collaborative work is needed. There are different kind of simple techniques you can use, or engage the people in like a short workshop, maybe 60 minutes, 90 minutes, whatever it is, where the team, and this is a recommendation, have the team try to express the product owner's vision in their own language, in their own way, using some kind of a template or mechanism. The team should be there to consult and provide information if the team wants to ask about it, but the expression should be the team's. Focus on the next release. Don't think like, no, of course, you will have a vision of the product for 3 years or 5 years, what are the scope of relevant planning, how you're going to change the world kind of thing. But the focus of this workshop should be on the next release, the next goal that the people are working towards collaboratively. When you have that workshop, only allow the team to select 3 or 4 critical elements in that expression of vision. Now, it's perfectly, and it's expected that they talk about all the different things that could be and are important, but they have to choose a limited number from that. The reason is, if you have everything, like 20 things that are important, how are you supposed to prioritize between the items in your daily work? So you need to force people to understand what's the most critical things. Fun is better than not fun, pretty obvious. And if you can incorporate visual elements in that workshop over text, also better. Visual forces us to think in different ways. Now, the next step, so once we've set an agreement that we work towards the same goal, we need to put more details on the steps that we need to do to get there. So user stories is a great way of doing that, but user stories are not good if they are written by the product owner and then only handed over to the team. Because user stories are not requirements gathering technique, they're not requirements definitions, they are conversations. Well, actually, they are reminders of conversations that we've had and that we need to have in the future. So the product owner of the team should absolutely write them together. And to write together means, for example, that you don't separate the group into subgroups. Like, okay, so the three of you, I'd like you to think about the end user. The three of you, I'd like you to think of the administrator. No, that's not collaboration. That's not the same problem. These are thinking same problem. It's not swarming together. So it has to be one group writing those stories simultaneously, sharing all the knowledge, having the same conversation all the time. Use physical tools like index cards and pens and paper and things like that, because it's easier to work together using those than, say, computers. In real life, we don't write stories based on just brainstorming. So there's always some history that precedes the moment, and that history should be brought to the present. But printing any materials you have available, bring present all the people that contain relevant information in their brains so they can write the right stories. It takes about 60 to 90 minutes to do this. If you spend less time, so probably not good enough. If it's more times, you go into too much detail. So somewhere in between that time seems to be the sweet spot. And to aim for about 30 to 40 stories, assuming that your project's something like, or the release something like 2 to 6 months of work. That way, with that balance, the people tend to write about the right level of detail. So it's the big picture, the big epics. It's not too much detail too early. So all users and features should be covered with at least one epic or one story. So once we have that, we are already closer to solving it in a swarming way. It's all foundations for that. The next step, the team should write the acceptance criteria. Not the product owner, not the stakeholders. They, of course, come from the product owner or through the product owner from the stakeholders, but again, by making the team write them, we can force them to actually study and understand what the criteria are. We sidestep one classical problem, that they get written first and then nobody understands, or the team doesn't understand it, and later on they try to understand it. We force them to understand it up front. Now, of course, you need to have the product owner there, possibly the stakeholders, so that they can confirm and check that the team has gotten it right and clarify any misconceptions that they have. So one more step even further into the level of detail. So remember, we need to be at all times, if we want to work as a team, if we want to keep swarming on problems, we need to keep the team together all the way through the different steps of refinement and clarification of the stories. So the story level design is the final plan at a sprint level. What will the system look like when this feature is done during the sprint? What would the system look like with this feature? For every story that you put in that sprint, you should have its own story level design. And that story level design incorporates all the aspects of that implementation in a single sheet of paper. I like to use the flip chart papers because that contains enough space. If you have a whiteboard, use the whiteboard. But remember, you gotta take a picture before you wipe it off and start on the next story. So I like to take the paper because I can take it and move it more easily. Just me, though. So it's user flow and the design, what it's going to look like, things like that. Remember, it's not just supposed to redraw the screen. You probably have screenshots or you have Photoshop pictures, so use those as reference, but confirm that we understand this the same way. Talk about what was the acceptance test, how are we going to do that, technical design and the testing. All the different aspects the team has to do. Sometimes even deployment. Again, it shouldn't take more than 15 minutes. So if you spend more than that, it's either because the story has not been well understood, or it's too large, or that we just didn't do enough clarification up front. Maybe 5 to 15 minutes per story is the ideal time. Again, use physical components, physical tools, physical presentations, and it should always be the whole team. Now, if you have a multi-team circumstance, like you have 5 teams working on the same project, then you have to come up with some tricks like combining members from different teams into a special team that does the refinement. But that gets, You have to figure out something anyway in those contexts. You can do something like that. But if you don't have to go there, have the whole team participate. Don't try to sub-optimize by having just some people, because then they're left out of the conversation. It's no longer swarming. This work, I usually have people do it at the latest in the sprint planning meeting, but it's actually a pretty good idea to try to start drafting that sheet of paper already in refinement meetings. Because once you refine it, you probably come up with questions. And if you don't do it in sprint planning, you do it before, you have still time to clarify before you have to commit to it. And if you've done this kind of design, what I've found out, the teams find it really easy to pull tasks from that design. Instead of, they become very small, granular tasks, and they clear and well understood. So the quality of tasks seems to be improving significantly if you use a story level design. You can also use a story level design part of your documentation of what you plan to do. Just take a picture of it, put it in a wiki for that story. So it doubles up as documentation. All right, so now we step from that clarification to stay on the same goal to maintaining that goal within the sprint or generally. So remember, it has to be the same problem we're thinking. So it has to be the same goal is synonymous to problem. So avoid anything that would create individual goals of any kind at any level in the project. Now, there are ways in which we, for example, if you have a product backlog and you put someone's name on a backlog item, that person is more likely to think about that, and other people are less likely to think about that problem. You just broke swarming. You just broke that teamwork element. So no names on stories in the product backlog. If you have to put a name there, use team. If you have multiple teams, it's okay to say team 1 might do that, team 2 might do that. But remember, then you break the team level, the cross-team swarming with that. Don't allow people to pull in the task in the sprint planning meeting. Again, if you do that, if in the sprint planning meeting with 2 weeks of work, I pull the items I intend to do this sprint, didn't I just create my own goal? It's get these tasks done. You have your own tasks, so you're going to focus on your tasks. That's not swarming. That's not teamwork. That is individual work in work groups. Only allowed people to pull items for their own in the daily Scrum meeting. Then it's only a limited amount of time. And even then, if you use something like a face magnet, a magnet with a label, initials or something like that, and you only have one of those, then you prevent that goal setting that people sort of pull items and just work on that list of things. They can only take one item at a time. So it also helps the enforcing WIP limits. If your tasks are small enough, like half a day on average, which of course you will much more easily get if you use the story level design, people can't go into a cave for very long. As an average half a day, they have to come out of the cave during the day, pick up another tasks, and going forward. You will know immediately, the next daily Scrum, if the person is still in the cave. And that indicates usually that they have some kind of a trouble with the thing, and you can go and help them. Now, that's assuming that you do tasks individually. Now, if we go deeper into that, let's talk about daily Scrums a little bit before we move into the more details on the task level. So different daily questions. You remember the basic ones that you can see from a basic Scrum textbook. Like, what did I do yesterday? What I plan to do today? What is blocking me? Now, that's a very individual based, isn't it? It talks about I, me. So in order to encourage collaborative work and swarming, I rather like these questions, which are all about collaboration. So I don't, what I did yesterday is clearly visible on the board. It's my face on it. So the team should already know about that. I don't have to repeat it. There's no value repeating it. Instead, I should. Of the things I did yesterday, what is of interest to anybody else? What do others need to know in order to be able to, interact with me and that we can collaborate? So what do others need to know? Second question is, everybody can see what I'm picking for today because I'm putting my name on it and I can show it on the board. But what they don't see is where I need help or how we need to coordinate those things. So that's what my second question should be focused on. Where do we need to work together? How should we work together during the next day? And the third question is naturally about impediments blocking any one of us It doesn't have to be an impediment that I see that's blocking me, but anything that I see that blocks any of us should be things I bring up. All right, so you can try that. You can also add a fourth question into the daily Scrum, further support the swarming aspect of things. Ask the whole team, are we still able to deliver on our commitment? Are we still in schedule to that commitment? And you can use thumb voting like, yes, we are. No, I don't feel we are. So as soon as anybody puts their finger down or the thumb down, you need to address that question. So how do we need to respond to this circumstance as a team to make sure that we have a plan we have confidence in? So once we go inside the task and inside the story in the implementation, one of the things that I have found, well, I have seen teams find very effective maintaining that collaborative atmosphere is to do the acceptance testing together. So it's not just that the testers are automating and writing the acceptance criteria and clarifying those things and then apply them on the things that the programmers did, is that you write those acceptance tests collaboratively before you even start coding. It's a great way to design and clarify the intent and what you have to do. It's probably easier to program against those tests than it would be otherwise. But work together on those things. When you plan how you're going to deal with this problem, write those tasks for writing the acceptance test into your task board so that you have them visible. If you have a task template that is for every story, that you have a certain standard set of tasks, write that task there. Automate collaboratively the acceptance tests. Now, it will help you collaborate on these if programmers know how to automate tests and you know how to a little bit how to write those scripts and what to think about them, how to do them. And it also helps if the testers know how to at least copy paste standard types of automated tests. Not all tests are unique. There's actually, most tests are very similar to one another. So copy pasting usually is something that even non-technical testers can learn with help. The programmers are there to help them to learn to do that, right? So once you get those skills sort of merged a little bit, it's much easier to collaborate on these things and work as a team on this. And the second thing about inside the sprint is pair work. So we're getting close to my end of my presentation. I kind of left the most classical swarming techniques to the finish. Pair working of any kind. Now, the classic version of pair working is the pair programming. But there's pair testing. There's pair exploratory testing. And you don't have to have just testers doing it. A tester with a programmer may be a very interesting pair to work on a exploratory testing case or scenario. Pair design. There are companies that are doing design and user exploration as a pair. Again, you don't need to have two designers doing it. It's actually a very interesting exercise to take a designer and a programmer to do that pair design at a company location. It has all kinds of benefits. Pair learning is massively powerful. So once you learn to pair learn, you can leverage two brains trying to figure something out and share that lessons with one another. So effectively, you can learn in a fraction of the time in best scenarios compared to individual learning and then sharing it. Now, when you do pair work, well, let's start with the pair programming. So when you do pair programming, it does matter how you do it and how it works. One of the ways in which I thought it should be done in the beginning was that the person at the keyboard thinks about the problem and tries to solve it, and the other person thinks sort of like a broader sense of things. But I've learned since then that it's not a very good technique, because the person who is trying to solve it, and if that person is on a keyboard, what they likely to do is, it's like, just a second, I'll show you. And then they're quiet for a while, typing, cursing sometimes, typing more, and the other person at the back is like, what the hell is he doing? All right, so you lose communication, you lose the thinking of the same problem, so you lose the swarming aspect. So the way you should instead do is that the person at the keyboard is actually not thinking about the problem. The person behind, who is the navigator, is thinking about the problem. And that person, as they walk and think, the funny thing is, it seems to be a lot of people walk when they think. And they don't have to look at the problem, they don't have to look at the code, they don't have to look at the keyboard, but their brain thinks about the problem and they speak what they're thinking. So do this. do that, build this construct. The more they are sort of experienced in pair work, the more abstract language can be used. And the person at the keyboard takes that language and translates it to something that the computer can understand, the code. Their job is just to do the translation. And then you switch, change the positions, switch again, and so on. Now, there's a special case of pairing. If you have one person who is significantly more senior or experienced in the problem, then that person should be the navigator most of the time. So you put the person who's not as good at the keyboard. It feels awkward at first, but people who get very good at technical coaching say that's the only way you can do it. That's the only way that the person this junior person actually learns something. Because if you're the senior person at the keyboard, you just keep writing. And the other person, like, I have no idea what's happening. And they don't learn. So you have to make them do it. It will take a while, but soon they will be able to start navigating more, and it becomes more equal. And plan for pairing in the daily Scrum. I do recommend that you put pairing as a standard component, that you don't do anything, at least not production code, without pairing as a foundation. But you shouldn't do design without pairing either. So you should have it as a standard practice. Whatever we do, it's always a pair. There's always 2 names on every single task. At least if you do that, then you are creating an environment where swarming happens all the time. Now, it doesn't have to limit to pairing. The most extreme form of swarming, which is in sort of my language, is sort of like the epitome of everything, is mobbing. In a mob, it's more than 2 people, and it's usually the whole team working on a single task together at the same time. You can test as a mob, you can program as a mob. I suppose you could design as a mob too, that'd be interesting. Now, the same recommendation I gave you for pairing apply to mobbing as well, but taken to the extreme. You have multiple navigators, only one driver. And it's even more important that the driver doesn't think, but you rotate frequently so that the driver changes and you get everybody thinking most of the time. The interesting thing about mobs, if you do mobbing consistently, not only is it the most effective way of writing code, according to those who've actually practiced it and do it, but it's also eliminating need for a lot of the things that we are used to in Scrum. You don't have to do daily Scrums. There's no value in daily Scrums because everybody knows everything all the time. You only work on one thing at a time, so your whip limit is 1. Those who know Lean know that that's sort of the optimum. You can't get better than 1 as a whip limit. And many other things disappear entirely. Communication becomes obvious. You don't have silos of any kind anymore. You get best of everybody on every single problem you do. And you get 4 people code reviewing the code that one person does. So it's practically error-free right off the keyboard. Anyway, I'm going to show you as basically the last thing I have, a video of an organization doing mobbing for 1 day. Okay, so I'm not going to show you the whole day. I'm sorry. I will not show every second of the day, so there's going to be a time lapse. It's going to be 3 minutes. It's not very long. So the company in question is Hunter Industries in San Diego. It is the home of mob programming. So they're doing everything in that organization, all the programming as mobs. They start the day with a shared skills learning session. They do mob learning there together, collaboratively, for an hour first. The definition is exactly the same as mine, except the words are slightly different. No stand-up meetings, those meetings eliminated. The teams are aligned. They do this all the time, every single day. Why do they do this? There's 6 mobs in that room. They do it because it's the fastest, the most effective way they have found to create software. They know how to create software so that each person sits at a different computer, but it's not good enough. It's not as fast and not as effective as they have. They have product owners present in the space, so they are part of the mob when they need them. They can move out when the team doesn't need it, but they come into the mob when they have it. So it's very cross-functional. It's a genuine team, and they're very happy. Okay, so they say they're happy. That doesn't mean they are happy, but as far as I know, I've met some people, one person there who was running this show at one point of time, and the reason they did it was because people loved it, and people were happy with that. They go to lunch together, but I suppose that's a practical thing. How can you mob if half the team is on lunch? Or at least not as a good thing. Some people, yeah. Some people ask, like, you know, isn't that like ineffective? And you know, for every feature you pay the cost of 5 people, but these people are not stupid. They're not doing this because it's fun. They do it because it's the most effective. Now, that doesn't mean that you have to be in the mob all the time. So you can see some examples of people moving out of the mobs to do something personal, email, whatever it is, on the side, and then they come back. So mobbing doesn't require that you commit yourself to 8 hours a day into that, sitting there with the rest of the people, but it does mean that you are most of the time there. Is that noisy?
That's amazing.
Yeah. And these, yeah, this is the most effective way they do it. It started off with one team doing it, and then the other team said, well, that's interesting. And they adopted the same practice because it was better than what they were doing. All kinds of things happening. All right. All right, 5 o'clock, the day ends, and thank you. That's sort of the end of my presentation at this point. So you had a question. If you Google, so you can find it, it's on YouTube, A Day of Mob Programming, I think. If you Google for that, you'll find it. It'll be there. And of course, you'll get this presentation and all of that afterwards, but yeah, you can watch it, you can show it. I think it's amazing a video, that's why I wanted to show it to you. Very inspiring. So the question was, how did I measure? I didn't. I know Woody Zuil, who was the manager of this organization, when they developed that several years ago, and they didn't do it because he had a master plan that mobbing is going to be awesome. It was something that actually emerged. It was a complex problem. How do we develop software as effectively as possible? But it started off with pairing more and learning collaborative techniques of various different kinds. And then there was some problem that they felt was so difficult and that it required everybody's input. So they ended up solving that problem by sitting in the same, working on the same computer at the same time. And at the end of the day, they said, holy cow, we got a lot of things done. And it was fun. Let's do this tomorrow again. And they never gave up that practice. They started, the first time they did it, they were in a meeting room. But they said, hey, we need to put this in our team room. And then that's how it started. And now there's 6 teams doing it. And it's spreading like wildfire in the development organization, development teams, people trying it all over the world, applying it to different problems. And, you know, I see a lot of feedback. Now, I'm not saying it works for you, and that's what Woody says. He's very careful to say, don't start with an assumption that mobbing is the best way to do it, but it might be an experiment worth trying, but it may not work in your environment. Get inspired by the ideas, don't mindlessly copy. But it's the extreme example of swarming. All right, in the middle. I recommend you don't try to sell it. Selling any ideas is usually a bad idea. Just start doing it. I mean, as a developer, as a team, assuming you are co-located, no one will know. Don't tell anybody. Only once you have learned the way to do it and you've actually, in whatever way works for you, demonstrated that it's a better way of doing things. You have confirmation it's a better way of doing it. Only then start, maybe talking about it, asking people to watch. Or they might start asking, how are we getting the velocity up? Or some other metric that you care for. Only then I recommend you start talking about that. You don't need to ask permission for these things. None of these things here require permission from anybody, or shouldn't require permission from anybody. If it does, then question the sanity of the workplace.
My question was how to sell this to the finish.
Well, maybe you shouldn't. That either. Or maybe you show this video and say, well, why is it that these people are doing this? Why is there 6 teams doing this every day if it's a bad idea? Show the video. Now, are we interested? Are we curious about this thing? I mean, maybe that could be one. Don't try to sell it, but try to find ways to make them curious. Do we want this? Because it does require, all of swarming requires that people make a personal desire, commitment to do it. So that requires that personal interest and desire to be part of that group and that swarm. It's really hard to force it without people's permission. Early on, as a coach, what I usually do if I go facilitating some of these techniques at a team, like helping them with the release planning and things like that, I use my position as a coach. I've been invited, so I'm expected to bring these things, and there's an implicit permission. So I just make them do things, and then I can ask afterwards, did you like this? If you liked, you might want to repeat it. If you didn't, well, I'm sorry. But if you don't have that leverage, then maybe just getting curious about that thing might work. There's a lot of materials on mob programming these days, so if you Google for that information, you'll find a lot of pages. But if you're excited, that's a good starting point. All right, anybody else? Oh.
You have 4 developers working on one feature.
Yep.
And what's the amount of work that they're done on the end of the day? So 4 developers do the work of the developer?
I don't know. But it must be more than 32 hours worth of work in a single person way of doing it, or whatever numbers you had, but it's more than the sum of the parts, because otherwise these people, because at Hunter Industries, they're not stupid people. They are trying to do things as smart as they can, and if they have convincing evidence this is a better way of doing things, they must have something to convince them of that. But that's why I'm saying it's their solution to their problem. Use it only as an inspiration. Find your own evidence. And once you find that, you might want to write a blog post about it, and either way. But yeah, I don't know those numbers, but all I know is convincing. Now, there are numbers for pair programming, that they overall save time and create better quality and less bugs and all kinds of nice things. But there are ways in which you have to do it to make it work right, and I tried to share some of the key things about it. Let's take one more question and then start closing the day, because it's been a long day for everybody. One more question, anybody? It's one at the back. These teams are working on in-house products. So yes, that means that they have slightly more control over the environment. So yes, but many of the things that, most of my experience is with consulting teams, working for somebody else. And I don't see too many problems of using at least some of these ideas. I mean, these ideas that used examples are from consulting environments where we are working, and never been a genuine problem to use them in consulting. Maybe the mobbing is something that it's more exotic. You got all kinds of interesting things that you have in consulting environments, like testers come from different organizations, are living in a different city. So those do make collaboration and swarming much more difficult. But maybe in the programming unit, you can still use it. So, all right. Thanks for my part. Do we have anybody coming on here closing the stage? Or is it the end of the day?
Once again, round of applause for Mr. Petri Heiramo.
Thank you.